This is the homework helper for Chapter 4, Section 3 in the 7th grade workbook entitled Identifying and Writing Proportions. Now, questions 1 through 12 have the same directions, so you're going to be using the same approach that you'll see in 1, 2, and 3 for the remainder of the questions in that section. And these are simply yes-no answers. We're supposed to determine whether the ratios are proportional. You saw 4 ways to figure out if these guys are proportional today. You can reduce the fractions and try and make them reduce to the same thing. You can use the concept of equivalent fractions and least common denominator. Write fractions with common denominators and see if the numerators are then the same. If they are, the answer is yes. If not, the answer is no. You can change these to decimals, and if they're the same thing, the answer will be yes, and if not, the answer will be no. Or you can use the concept of cross products, and if you multiply the diagonals and you get the same result, the answer is yes, and if not, the answer is no. Alright, so let's start by going through these questions here. In the first one, we're going to go ahead and use the idea of reducing the fractions because it's kind of set up for that. This guy on the left here, 3/4, is already reduced. This one on the right here, I can reduce 24 and 32 by dividing out its greatest common factor, the greatest common factor of 24 and 32 being 8. So I'm going to divide 8 out of each of those guys, and when I do that, I end up with a result of 3/4. Well, since my original fraction said 3/4 and my other fraction says 3/4, the answer here is yes. These guys would then be proportional. In number 2, 5, 6, and 15/18. Again, you've got all the choices in the world here. You can try and make a common denominator or reduce if you want to stick with fractions. Since I see 6 and 18 here, let's go with the idea of the least common denominator. Least common denominator of 6 and 18 is 18. So to go for a common denominator, that means I'm just going to have to change this guy. Well, to make the bottom number go to 18, I'm multiplying by 3. So I'm going to multiply the top number by 3 as well, and that's 15/18. Well, since both of these fractions say 15/18, the answer here is yes. These guys would then be proportional. And in number 3, let's use that idea of cross products. Again, what you're going to do is multiply the diagonals and hope you get the same result. So on the one diagonal here, with 10/12 and 20/32, 10 times 32 is 320. The other diagonal, 12 times 20, results in 240. Well, since I got different results here, the answer is going to be no, that these are not proportional. Had I gotten the same results here, the answer would be yes, that those are proportional. Alright, now we'll take a look at 13 through 18, which all feature the same directions. We are to find a ratio equivalent to each ratio and then use those ratios to write a proportion. So when you're coming up with an equivalent ratio, you can multiply or divide both the numerator and the denominator by the same figure, and that will generate your equivalent ratio. So think of the concept of equivalent fractions because it's really the same thing. So with 7/9, I'm going to decide I want to multiply both of these guys by 2. When I say both of these guys, again, I mean both the numerator and the denominator here. Well, 7 times 2 is 14. 9 times 2 is 18. So there's an equivalent ratio. Now, it's asking me to then write a proportion. The proportion will be a statement that says that those two ratios are equivalent. So 2 fractions with an equal sign between them. So on the line, I'm going to write that 7/9 is equal to 14/18, and there's my proportion. In number 14, 11/12, I can't make this guy any smaller. I can't really divide, at least if I just think of it as a fraction. So I'm probably going to multiply. Remember, one of our favorite tricks when working with equivalent fractions is to multiply by 10. Because all that's going to do, unless there's a decimal parent, which there could be now since these are ratios and you're allowed to have that, but if not, all that's going to do is add a 0. So multiplying by 10 is going to generate 110 over 120. And now what I'm going to do is issue a statement that says my original fraction or my original ratio is equivalent to that ratio, which is my proportion. So 11/12 is the same as 110 over 120, and life is good. Finally, in number 15, you've got 14/15. Again, you're going to multiply by the same number, numerator and denominator here. Pick any number you want. You could divide. but this one doesn't reduce, so that's not going to be a viable option here. So let's say I'm going to go back to multiplying by 2 here. Well, when I do that, that gives me 28/30. And there's my equivalent ratio. And now I write a proportion, which is again a statement that says those two guys are equal. So I'm going to say that 14/15 is the same as 28/30. And there's my answer for number 15.